Okay, so we stopped here earlier. So, okay. So, na-verify na natin itong mga to. So, we just need to plug that sa ating B matrix. Take note again, everything here is in terms of coordinates, right? Yung alpha 1 natin, x2, y3 minus x3, y2, coordinates yan. So, ating dn dx, so that is a real number, okay? Okay, dn1 dx, ito yon. Or simply, B matrix is 1 over 2a, beta 1, beta 2, beta 3, okay? Gamma 1, gamma 2, gamma 3, so on and so forth. Now, we know from the start that our K matrix is this. No, even in axial, in beam, we've been using this. No, B transpose dB d omega. Okay. Since B and D are constant matrices, the above expression can be expressed as K equals B transpose dB, okay, triple integral volume dB, right? So, constant yung B transpose dB. Okay. So, simply, volume, no? For a constant thickness, T, the volume of the element will become area times the thickness, right? So, K will now be equal to B transpose dB AT, this one. Okay. Now, for plane stress condition, so this is being discussed elasticity. Okay. From a separate video. No? For a plane stress condition, your D matrix will become this. Okay. Unlike with the beam and axial member, ang D matrix natin is simply what? E, the Young's modulus. Okay, for the plane stress condition in two-dimensional element, this is our D matrix. Okay, now plug in natin yan dito. Okay, your element stiffness matrix becomes ito na. Okay, again, this is B transpose, this is D, this is B. Okay, ito yun, no? This one is ito. Sinama lang yung 80. Okay. Ito yung thickness. Okay. So that's it. And when you operate that, you now have your stiffness matrix. So ito kahit huwag na nyo nang pansin ito, no? Pinahaba lang naman. No? But again, when you have a code for this, so madali na yan sa SMAT. Okay, so that's it. So we will have an example of this. So ganun lang ang 2D element, constant strain triangle. Okay. So saan nga ulit ginagamit si constant strain triangle? Okay. For examples, in a you can use that in heat transfer. Okay. Problem. Okay. That's why if you use that, make sure na yung mesh size of the triangular element should be small enough to get correct results. Kasi nga constant siya. No? Otherwise, pag malaki yung size ng element mo ng triangle na to, yung temperature gradient mo mali na. Okay? So, let's proceed with the example. Okay. Constant strain. Where's that? Ito. Okay, determine the displacements of the nodes for the following 2D solid continuum. So, ito naman, in a plane stress problem. So, meron tayong plate having constant thickness. Okay. which is 25 mm. The Poisson's ratio mu is 0.25. Modulus of elasticity is 2 times 10 raised to 5. So more like this is a steel, no? Steel member, steel plate. Okay. The continuum is discretized with 2 CST plane stress elements. Okay, so where's my S? Meron na tayong S-mat niyan. This one, open. Yan, okay. So ito yung implementation niya in S-mat. Okay. So dito nagawa lang ako ng mga coordinates, no? Matrix indicating the coordinates. So for example, we have 1500 and 500. So hinati into two elements yung plate. Okay. For example, for element 1, so ano yung coordinates niyan? Say this is 0.1 and then 1, 3, 4. Okay. So this is 0. Saying this is 0. So ano naman yung x nito? 1500, of course. And then ano yung x nito? 0. That's why. For the y1, 0, of course. Ano yung y nito? 500. And then ano yung y nito? 500. Okay, so we're dealing with element 1 here. Okay. Then yung coordinates, 1, 1, 1. Ito yung nasa lecture here. Where's that? Here. Yan, no? 1, x1, y1. 1, x2, y2. 1, x3, y2. Here. 1, x1, y1. 1, x2, y2. 1, x3, y3. Okay. What is the area? So, simply get the determinant of this and multiply mo sa 1/2. Yun yung area. And then, E is 200 gigapascal according to our problem. And then, okay, our Poisson's ratio is 0.25 and the thickness is 25 mm. So, given naman yung, minimize ko to. Where's this? Okay. So, yung alpha natin is here. There's alpha. Yan, okay. Alpha matrix. So, x2, y3 minus x3, y2. Okay. And the beta, y2 minus y3. Okay. You will notice, ginawa ko ng matrix to. Alpha 1, alpha 2, alpha 3. Which is this. Okay. x2, y3, x2, y3, x3, y1, x3, y1, x1, y2, x1, y2. Okay. Minus x3, y2. Okay. Ito yun, no? How about the beta matrix? Ito naman yan, no? y2, y3, y3, y1, y1, y2. y2, y3, y3, y1, y1, y2. And then the gamma, x3, x2. Ito yun. x3, x2, x2, x1, x2, x1, gamma 3. Ito, no? Mali pala ito. x3, x2, okay, x2, x1. This should be x1, x3. Ito. Gamma 2. Yan, x1, x3. This came here. x1, x3. So, tama naman to. x1, x3. And then, to get the B matrix is this. Okay, or here. Yan, no? The B matrix is 1 over 2A, beta 1, beta 2, beta 3. Ito na yun, no? Beta 1, beta 2, beta 3, gamma 1, gamma 2, gamma 3, okay? Gamma 1, gamma 2, so on and so forth. Then, you now have the B matrix here. Okay? So, kagaya ng concept sa beam, and even truss, actual member, kailangan natin maggawa ng null matrix having 0 element. Okay? So, ang S4 ko is 3 by 3. Why 3 by 3? Ilan ba ang displacement nito? If you notice, again, we have 2 displacement at each joint. Okay, so pin tayo dito, pin tayo dyan, roller lang dito. No? And then, no supports here. Therefore, may displacement dito. No? So, kung ito-drawing ko siya dito, file, save, okay, and drawing ko siya dyan. So, meron tayong 2 degrees of freedom dito, and then 1 here, right? Kasi roller lang dito. Dito, pin, no? Therefore, we have in total 3 degrees of freedom, or 3 displacement. Kaya, ang ating S matrix is 3 by 3. Okay. So, continue. So, kung ano yung ginawa natin sa element 1, ganoon din yung gagawin natin sa element 2. No? Babaguhin lang natin yung coordinates. And then, which is that. Okay, of course, ang ginamit ko dito is C, no? Instead of D. No? So, ito yon yung ating D matrix. So, E over 1 minus mu squared. Okay, yan. Ha? This is it. Okay. And then, implement natin itong formula ng K, D transpose D, VAT. So, thickness times area, D transpose CB. Ito din yan, no? Okay. So, that's it. This is our K matrix for element 1. Okay. And then, we repeat the same process element 2. Okay. So, ito yun. I-repeat lang natin. Except that yung coordinates lang yung nagbago. No? So, we have now K2. And this is our K2. Now, I will insert ko ulit dito yung ginamit kong code to get the S matrix from each element. No? Ito din yung ginagamit ko sa axial at saka sa beam. Of course, ilulup ko siya into 2 kasi dalawa lang naman yung element ko. No? And then, I found my total S matrix as this. Okay? But before that, let's talk about this. Yung ating BU and BB. So, ito yung even sa beam and axial, ginagamit na natin ito. No? Again, BU matrix, ito yung address ng mga stiffness values na kukunin natin. Or stiffness, element stiffness value from the, na-i-extract natin from the stiffness matrix of each element. And then yung BB matrix is yung address ng mga yon, no? Oops. Then, so, where's that? BU natin ulit is ito. So, I have to explain this further. Here. Where's that? Ito. So, save ko muna. Okay. So ito yung ating problem. Yan. I set this as node 1, my node 2, my node 3 for element 1. Therefore, kung extract ko to, this becomes degrees of freedom 1. This is degrees of freedom 2, 3, 4, 5, 6. Okay, while here, for element 2, where's that? Check ko lang yung ano. Element 2, 0, 1500, 1500. 0, 1500, 1500. 0, 0, 500. So, ito naman yung ginawa kong ano. Ito naman yung ginawa kong direction pag ganun, no? Counterclockwise, no? As much as possible, consistent yung ano natin, yung orientation. So, ito naman yung ginawa kong 1, 2, 3. Or, this becomes 1, 2, 3. So, 1, 4, 3. Okay. Okay. Okay, so my BU is equal to, let me see, 25356. So that is 25356, and my BB matrix is 1, 3, and then 1, 2, 3. 1, 2, 3. Okay. So that means, remember, meron tayong displacement dito, tsaka dito, no? So, dalawa dito, tapos isa dito. So, may movement ka dito. Okay. Okay, so i-correct ko lang yung coding pala sa CST, no? For sa plane stress. Remember, ang inuna natin sa matrix natin is U1, U2, U3, no? Sa derivation. So, inuuna lahat ng displacement horizontal. Okay, in that case, so save ko muna to. That means this should be 1, 2, 3, and then 4, 5, 6. So for here, this is 1, 4, 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay. So this is 1, 4. Sorry. What is this? Yeah. 1, 5, 6. So this is 7. And then this is 2, 5. Okay. 1, 7, 2, 4, 8. This is 8. Okay. So, meron tayong degrees of freedom dito, no? Na affected si element 1. Kaya, ang kinuha ko na required sa element 1 is 2 and 5. Okay? For element 2, So, ito naman si element 2. So, element 2, meron kang displacement dito, and then meron kang displacement dito. Yan. Okay. So, 3, 5, 6. 3, 5, 6 kasi babalikan natin yung K ng mga to. No? This is K. K1 for element 1. Coding nito is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 by 6 kasi we have 2 degrees of freedom each joint. We have 3 nodes each element. So 2 times 3 is 6. So 6 by 6. While for K2, ang coding niyan ay 1, 7, 2, 1, 7, 2, 4, 8, 5. Right? 1, 7, 2, 4, 8, 5. Ayan yung coding. No? Okay, oops. I need to save this first. Okay. So, we now know that what we need for element 1 is 2 and 5. That is this, 2 and 5. And for element 2, we need 8 to 5. So, we need 8 to 5, which is this, this, and this. Right? 8 to 5. And the address of that is 3rd, 5th, and 6th. That's why 3, 5, 6. Okay. And then our S matrix, you follow yung concept ng ating the S matrix from the axial to the beam. Ganito tayo mag-coding. Where's my S? Ano ang code for S? We said your S is simply yung unknown displacement. So we have 3 unknown displacement having code which is 825. So lagay ko dito 825. 825 halimbawa 825. Okay. So settle na tayo dito. Settle na tayo dyan. Okay, 825, 825. Okay. So, si 2 and 5 from K1, saan siya mapupunta dito sa S? Nandito. Sa pangalawa at sa pangatlo. Yan. Okay. Or in my case, sinet ko yata siya na 258. 285? 285. 1, 2, 3. Yeah, 285. Set natin muna. Say set ko 285 na lang. Pwede naman yun. No? Set ko siya na ang code ay 285. No? So, saan mapupunta si 2 and 5 here? 2 and 5. Anong position ni 2 and 5? Here, here, saka dito sa dulo. Or in short, position nila ay first and third. That's why ang BB ko is 1 and 3 for element 1. How about element 2? Yan. Saan mapupunta yung 285? So simply, 1, 2, 3. Lahat sila involved kay element 2. 285. Okay? 285 will be 2, 1 here. 8 will be the second. 5 will be the third. That's why 1, 2, 3. So that's it. Yun yung explanation niya nung code na yan. Okay, so save. Okay. So, okay, settle na tayo dito. So, once as you have this now, i-read kasi yan ng code na to. No? Itong code na to. Then, it will now come up with your S matrix, which is 3 by 3. This is 3 by 3, 3 by 3. Okay? And then, input mo lang yung vector matrix mo. Force vector rather. So, from concept ulit ng ating P equals SD. Alam na natin si S. Your P vector is yung given sa problem. That's the time we now get D from S inverse P. So that is negative 25,000 kasi yan yung given sa problem. 25 kilonewton. So 25,000 apply and you have this displacement. Negative 0.156, 0.0606. Copy ko to. Yan. So, insert new page. So, yan daw yung displacement. Remember, ang code natin dito ay 285. This is for 2. This is for 8. This is for 5. And then, where's that? Here. 2, 8, 5. Copy ko to. Masyado ano. Okay. Okay, that's it. So, 285. So, yung horizontal displacement dito is 0.0156. Vertical displacement dito is negative 0.0606. So, going downward kasi pababa yung force natin. And then, the vertical displacement dito is also downward, kaya negative. And what did we get sa ating problem? So, the same lang. No? Okay. So, 0.0606, 0.0156, and negative 0.0612. Okay, so that's it. So, let's continue later. Another video for rectangular.